Good afternoon, everyone, and thank you for joining today. I feel like my talk is exactly a continuation of Rob's talk. Before that, we're going to talk about like Cloud DevOps. Well, really, this talk is for security folks who are moving into the cloud. So we want to see like how do we apply security measures in a cloud/DevOps world. My name is Ahmed. I live in Chicago. I work for CDW now, and I manage a team that does incident handling in cloud. So we do that, and then we also develop our own applications. So we've been through this journey of like moving from traditional security to cloud-based security. I also teach for SANS, and I teach the exact same thing. Basically, how do we put all of that into the DevOps environment? So with that, this is a very short introduction, right? We're going to talk about what DevOps is really quickly, because you already know that from the previous one. We're going to talk about some of the tools quickly, and then we'll dive into security, and we'll see how does that all tie together. So to begin with, I'm not going to ask you to define DevOps. You already done that in the previous talk, but let's talk a little bit of history. Historically, there was a separation between development and then infrastructure or operations and security as well. So you got these three things kind of separated from each other. With the introduction of DevOps concepts and with cloud making that even easier, things are kind of merging now, right? So you don't have that separation. And if you really think about like the DevOps logo itself, you will see that it has two parts. There's dev, and then there's the ops, which is the operation. And it always starts with, hey, we're going to plan this type of project. We're going to write some code, and that code is going to be built and then tested. And that is all part of what the developers are doing. Sounds good? Once we have that code tested, now it's time to put it in production, right? So we're going to deploy it. And we're going to deploy it. We're going to run some tests. There are certain operational tasks that we want to do. We also want to monitor and measure. And then we want to learn from that and then feed that back in and continue to the development. Hence the name continuous integration, continuous development. Sounds good. So that kind of changed how we do things. And the question is, how is that really related to security and in specific in cloud security? Now, to answer that, let's take a look at some of the major changes, or like one of the major changes that changed when it comes to security. Anyone here from a security, like strictly security background? Yeah, so are you familiar with like the code and how security people hate code? I used to hate code, right? So that's the first thing that changed, right? Now, everything you do is basically code, whereas previously, my first job was a Unix admin. What I used to do is basically go and like rack the servers, physically connecting them and install the operating system, whatever the application team requires. And then I would apply some security because I had a checklist. And that checklist was basically, hey, disable the service, open SSH, make sure that the system is patched, make sure you use the golden image, which was a CD. Now the question is, do you think every time I did that, I did it exactly the same way? Or maybe sometimes I forgot to do certain steps, right? And then once I forget, I would probably remember that the day after, and I was like, oh man, I forgot to do that. I probably need to log in. So manually, I would log in to that system, and then I would make that change, right? So now I have secured it. Do you think there was a good way of measuring? So would my boss know exactly if I did a good job or not? Yeah, I see. Yeah. Some people laughing, of course, because for that to happen, there has to be like some level of trust, right? And then once a new engineer comes in, do you think that new engineer will do exactly the same thing that I'm doing? It could be more, it could be less, right? That is changing with code. Now we're using code pretty much for everything, right? So think about from the beginning, racking those servers, that's gone, right? In cloud, you just create code that creates infrastructure. You do not also point and click, right? It has to be repeatable. Once you have that infrastructure, so that is your network, that is your security groups, your VPC, your subnets, all of that, then you build your instances. Once you build your instances, you still need to configure those. So remember me logging into that instance or that server and making changes, that's gone too. Now we have configuration as code. So think about things like Ansible, and Chef, and Puppet. Now there are a lot of tools in here, so keep that in mind. That's one of the challenges. Now that we have that, how about we throw some container magic into the mix, right? Who here understands exactly how containers work? Nobody? I have some understanding, right? I know that it has to do with Linux kernel, right? And its capabilities. It's a very complicated topic to understand, but it does magic for us. And apparently, as security professionals, we are expected to know that too, right? So that's a whole new area. But also that is code as well. So the way we build containers is by creating this Docker file that is basically code-ish that is used to configure this container. So that's fine. That can be considered code too. What else do we have? Well, obviously we have the application code itself. That hasn't changed, right? The only thing is that now we're more close to it, whereas previously you had to have someone who's an application security professional so that they know what they're doing in terms of application. Those were like a very small number. Now the security professionals have to be closer to that. We have to understand the application code more. One of the things that I recently, well, not recently, but I learned is that documentation is also being done by code. This is amazing, right? You've got tools such as Terraform docs that will go through your Terraform code and it will create a document that tells you this code creates these resources, it takes this input, it produces this output. Fantastic, right? Now, we also have other things that developers are very, very familiar with, but we're not. So these are the automated testing. So it was mentioned in the previous one, Rob mentioned Selenium testing, right? There are different types of testing that developers do. Maybe we can take advantage of some of that. Now, also, all of these different tools, all of these different types of languages, quote unquote, right? Most of it is YAML, so one language. So if you know YAML, you know so many tools, that's great. But then in order for us to have all of that, we have to tie it together somehow. There has to be something that glues all of this together. And this is where the deployment pipelines come in, right? This is the gist of our discussion. So these are tools such as Jenkins, AWS CodePipeline, GitHub Actions, etc. And these have their own languages as well. If you're unlucky to use Jenkins, you would have to learn Groovy, right? But if you're not using something else, maybe YAML can do, you still have to learn a few things. So now we look at our infrastructure and all of a sudden it's all about code. And if we do not really know how this works, it's going to be a little bit challenging. And that is something that we see security professionals kind of a little bit struggle with. To illustrate how this works, you get a bunch of engineers, right? And developers and AI nowadays, right? We're creating code and maybe we're using a tool such as Microsoft Visual Studio. All of this needs to be stored somewhere, right? And there's a big history about like where do we store code and what do we do with it? Well, AWS CodeCommit could be one tool. This is an AWS adjacent event, right? So all of the tools are going to be AWS, but you don't have to use CodeCommit, right? You can use GitHub, GitLab. We got GitLab as a sponsor in here. Bottom line is all of this code being produced is stored somewhere. What happens there? As soon as we put that data in, there would be some sort of a process that will kick off. This process would take whatever that code is, will run through a pipeline, and then eventually will build the infrastructure / application / container images, whatever we are building, right? So now we check it in, there should be a process, and in this case, that would be CodePipeline with the help of CodeBuild, as an example, right? This is a simplified view. And it will do this certain magic, and that magic will produce infrastructure for us. All right. Anyone has concerns about this so far? Do you see like security issues in here? Let's zoom in a little bit. Let's zoom in on the process of creating this pipeline. The pipeline, if you are using AWS CodePipeline, would look something like this. So let's kind of digest what's on the screen. Who have used AWS CodePipeline before? Who has suffered using AWS CodePipeline before? So we were talking about this earlier, where CodePipeline is great because it's almost free, right? It's not that expensive. You could do it if you are a small team, such as my team. You can use it without any headache of managing any other system. It does kind of have some pain points, but it gets the job done. If you're starting off, maybe you can use that. Let's say you're running Terraform. You're using Terraform to build infrastructure, right? You can build it in a way where there are multiple phases, and each phase will do one specific thing or a group of things. In security, that would be maybe you want to run certain security tests, right? So if you look closely, I don't know if you can see this. I'll try to use my cursor. This is the first step, where the code pipeline basically gets the code from. It just clones the code in preparation to do something with it. And you can choose to do certain things. So for example, this new stage is called static code analysis. More on this later on. And if you look closer, you would see that two things actually are here. Checkoff and HeyDolent. Both of these are security tools. Checkoff scans infrastructure as code and a bunch of other things. HeyDolent scans Docker container images, well, Docker files, right? So you're using this to basically scan your code. So that's the first. How does this work? Well, CodePipeline integrates with CodeBuild. It creates CodeBuild projects, one project for each task. Now, that has an advantages, and it also has some disadvantages. One thing is that this CodeBuild project is actually a container, right? So it runs on an image, which means you don't bother if you don't see it. There's another slide that basically will explain all of that. But what that basically means that the pipeline will spin up this container, will put that code in that container, and then we'll scan this code, and then it will produce results. These results could be stored as artifacts somewhere else. So maybe in a bucket, maybe in a tool, we want to create reports, maybe it will send it to CloudWatch, right? I will have to do something with these results. Maybe if there are specific security issues found, maybe I'm going to stop this pipeline, right? That could be arranged too. And that's basically the point of it. Now, code build projects are based also on YAML. There is this spec file, and the spec file has the instructions of what needs to happen inside this container. So again, this container pops up, it scans your code, and then it just dies after storing this the result somewhere. Another one then pops up, does Terraform plan, right? And then it works with that, and then maybe it shut down. Another one pops up and say, hey, now I want to apply, and that's what actually builds the infrastructure. All right, sounds good. Let's zoom out a little bit. Now we understand like this process. And I think this is the most important slide I have for you today. Are you guys familiar with defense in depth? In cybersecurity, defense in depth means that we have different layers of security, and we want to apply those independent of each other. So for example, if I have a server, I need to make sure that server is patched, regardless if that server sits behind the WAF or not. Right? The WAF, the web application firewall, could provide me with virtual patching. So attacks come in, they will be stopped at the WAF, but I still have to assume that that WAF might fail, and therefore I cannot say that, oh, because I have a WAF, I don't need to patch my server, right? So that's defense in depth simplified. This is the same thing, only now we're looking at the DevOps workflow. And you can think about it as these 5 stages. So pre-commit, that's before my developers push anything into production. That is my developers basically writing code and putting it locally. And then I have the commit. That is once the developers hits, hey, get commit, get push, right? So now you uploaded your code, you pushed your code. Once the pipeline picks that up, that's the acceptance phase. I'm going to run these tests that we're talking about. And then I'm going to push that into production, and then I will monitor it, do incident response, what have you. In each one of these phases, there are so many things that we can do. And that could serve as a map, right? So let's talk a little bit about some of these. So pre-commit hooks, right? Under pre-commit. Do I want secrets in my code? What if one of my developers wants to push secrets for some reason, right? Maybe there's a pre-commit hook that will basically provide an alert saying, hey, by the way, your code has something that looks like an AWS access key, right? So that's what that is. We don't have time to cover all of these. So I have chosen one of each to kind of talk about and see like, what can we do with that? So we're going to begin with the IDE security. We're going to move to static code analysis. We already talked a little bit about that. We'll move to dynamic testing, then secrets management, then finally end the discussion with continuous monitoring. So with that, as a developer, as an engineer, or as a team of engineers, I'm using tools to write all of this code and produce it locally. It would be great if there are tools that would actually help me secure it in a way. This is where if you're using Microsoft VS Code, you can use the plugins. And the plugins are basically scripts that use some of these tools that are installed locally. So as an example of that, the screenshot that we have is taken from my VS Code. And let me use the cursor. So this is a security group, and that security group basically is underlined. And when you point at it, this description will happen. And I don't know if you can read it, but I can read some of it. It basically tells us that this security group has some issues. It's a bad one, right? You need to do things with it. So that's me as I'm writing code. This is coming from a tool called CFNNAG. And CFNNAG is a tool that is specialized in scanning CloudFormation templates. If I'm writing Terraform, I will probably need another tool. These tools have to be installed locally on the developer's machine, right? That's the development environment that they're using. Anyone sees an issue? Pipeline? We will get to the pipeline in a minute, but yes. But how about guarantees, right? If I have this, does that mean that developers will actually fix it? I mean, maybe, right? The other thing is, there are so many tools. I mean, this is just this is a sample of them. How do I guarantee that these engineers actually have these systems on their machines? Well, there are so many ways to address that. One of them is basically using Ansible to configure these machines with these tools. So that's one approach. So you had a question.
What I was also going to say is some of these tools require configuration.
Yes, exactly. Yeah. So you have to configure them, right? So that's another add. So who's going to do that? If you have a team of 5, right? Maybe what you want to do is maybe have like one machine, one server, and then everyone connects to it because VS Code has the ability to remote into different machines. So maybe that's one approach, right? So now you have to manage one machine, one development environment, and then everyone else is connected to it. That's one approach. But regardless of that, because we have these limitations, we want to also do the same thing, but now we want to do it in the pipeline. So this is where we enforce things. In the previous step, this is more like suggested, right? Hey, you probably need to fix this. So now we talk about static code analysis. And the name static comes from the fact that everything we do, we're doing on the static files. We're flat files, and we're reading these files, not as humans, but as code, some sort of a tool that's reading these files and telling you, hey, you have certain issues. This security group is bad. This is actually the exact same results. Only now I'm running CFNNAG on this main.yaml, which is a CloudFormation template. And it's basically telling me, hey, you got this subnet wrong, the security group. I'm doing an awful job, basically. And you also can see that some of these are yellow and some of them are red. And that's the difference between warning and an error. Maybe I would like to configure my pipeline to stop the build if there's an error, right? If there's something that is serious. And maybe I need to have a threshold, right? That says, hey, more than 5 of these cut off, like do not continue. If all of them are warning, maybe just mark this pipeline as unstable and move on. Now, there are certain things that we need to be aware of. One, these tools have to be fast, right? Can I run a static, any type of scan that will take 30 minutes? Does that go against the DevOps strategies, right? I need to do things fast. So that's one thing. I also need to be able to run these tools headless, which means they need to run either command line or maybe through an API call, but not a graphical tool that I point and click. That's all. We don't do ClickOps, right? Do we? So that's the thing. Many of these tools, unfortunately, were developed before DevOps. Now, CFNNAG obviously is not one of them. It's designed for CloudFormation templates, but there are others that are. So this will require some research on our part to kind of decide, first of all, what is the technology stack that we have? And then based on that, what are the tools that are suitable for us to use? These are some of the suggestions, right? So we talked about Halo-Lint. If we're using Terraform, there are a whole set of tools. And then you also have the OWASP dependency check. That's an important one, right? Unfortunately, we'll not talk too much about that. All right, so that's good. We have a bunch of tools running static code analysis. Everything is fine. Now the pipeline is moving to the next stage. Now the pipeline has built the infrastructure. So now I do have an infrastructure, and I do have maybe some serverless application, or maybe an application that runs on EC2 instances, Kubernetes, whatever you want. And then now that application is ready to be interacted with. And interacted with is the key word. because this is dynamic security testing. Now I'm going to interact with this application and sort of do some sort of a vulnerability scan, if you will. I'm going to send requests to this application, and then I'm going to receive results back. This is drastically different from static code analysis, right? Where I do not have an application to communicate with. This will basically uncover things like SQL injections, for example, right? I can still uncover that based on static code analysis, but now I have a more in-depth knowledge. I can test this with it. The same principles apply, but they're more important here, especially the speed one, right? Has anyone here ran maybe SQL map or Burp Suite? How much time did that take? 30 minutes, an hour, depending on the application, right? Sometimes longer than that. Does that work in a pipeline? Not really. So what do? Well, there are two things to consider here. Well, one, I probably need to create a solution that is custom to my application. Custom meaning that I want to strip it down and focus on the most important things. Does this also mean that I still have room for something like dynamic analysis outside of my pipeline? Because I didn't run everything inside the pipeline because of the speed limitation, right? So maybe I want to create another deployment environment. So I usually have a dev, maybe a QA, and then I have production. Maybe I can have a QA or something similar that is only for running these types of scans that are time hungry. They're also CPU hungry, right? Resources hungry. So it's not just that the dynamic scan is slow, but it also consumes a lot of resources. So running that in a container maybe is not the best idea, right? So maybe I need to take it off. What about things like penetration testing for my application? Right? Does that make sense? So maybe I have the same environment that I've created for anything dynamic, anything that would take time. Maybe I can use that as well for something like a penetration testing, or maybe a more thorough vulnerability assessment for this application. And by the way, when I say application, that includes everything, right? The application itself, the infrastructure, everything I created with code. All right, so moving on, the next topic that we want to pay really close attention to is secrets management. Because there are nothing manual, somehow all of these different systems need to share secrets. So think about the AWS CodePipeline when it needs to create infrastructure. Does it have to have some sort of roles involved, right? It needs to have some sort of an access to be able to do that. What about reading code from CodeCommit or GitHub? Does that mean that, let's say, Jenkins needs access to GitHub? How is that going to happen? There probably will be secrets stored somewhere. Are these secrets stored in code? Obviously not, right? We don't want to do that. So therefore, there are many solutions, secret managers, that can help us do that. And there are different types of secret managers. There are ones that are cloud native. So if you are all in AWS, you have many options. So KMS being one. Anyone uses SSM parameter store to store secrets? We do too for some projects. Yep. Is it fantastic and free? Yep, it's amazing. Every few months we meet, the team and I, and we say, hey, do we have any reasons for not using SSM? And everyone says, no, that's great. I mean, we love it. All right, there you go. So that's one solution. It has limitations, of course. If you want to do things, once we grow, I'm sure that at some point we will move to something like KMS. What if I'm in both, in AWS, but also in Azure? Maybe I need a different tool, right? So I have a lot of options. One of them is Vault. So Vault is another option that's basically standalone. The pros is that it can basically be your centralized storage for everything. The con is basically you have to manage it. You have to actually work with it. You have to make sure that's actually secure. And speaking of that, does this mean that these security managers are a perfect target for attackers? So it used to be, well, I shouldn't say it used to be, but if you're handling an incident, probably what would happen if someone phishes one of your employees, the next thing that the malicious actor will do is maybe scan your network. So Nmap, right? It's not the case anymore. Probably what they're going to do is find out your sources of documentation. So SharePoint, for example, and then maybe try to find what type of DevOps infrastructure applications you have and solutions you have. So they will find your GitHub, your GitLab, whatever you do. They will find your Jenkins, whatever orchestrator you're using. And then maybe they'll try to exfiltrate secrets. If you are a malicious actor and you land access in, let's say, GitHub, what's your next step? Anyone?
Run through the history and look for secrets in code.
There you go. How do you do that? You just search for it, right?
There are tools for that.
Yeah, there are tools for that, but you can go and just in the search bar say password and then hit enter, right? And probably you will find something. You can also search for keys. So you can search for something that looks like an AWS key. They all start with the same 4 letters, like they're like a bunch of, I think 10 or so. You can also search for encryption keys, so PGP keys, certificates, etc. It seems like this is a gold mine for attackers. This also means that this is something we really need to pay attention to when talking about secret management. So how do we manage that? So that is one of the reasons why we use SSM parameter store. It's much easier for us to secure, right? Roles, and we assign them, make sure IAM is pretty tight, and that's about it. Rather than having a Vault server that now we have to have an expert in Vault, or someone has to learn Vault, and then we basically have to spend time managing this. All right, so with that, finally, the final topic for today, not finally, continuous monitoring. So that's another example of things that we can do within the pipeline itself and within the, not the pipeline, but the DevOps environment itself. So we have pushed everything in production. What if something goes wrong? Do we have, or does the cloud provide us with many tools that will allow us to mitigate these things? So as an example, maybe I would like to create a CloudWatch alert. Then that CloudWatch alert would look for a specific event. And once that event happens, it will trigger a Lambda that will basically counter that event. So block users access or strip user from roles, right? What if I have an instance that I have reasons to believe it's infected with some sort of a malware? I could kill it, right? Within cloud, that's fine. You know that's okay. But what if I need to do some sort of forensics on it? Maybe I can have a Lambda that will basically go in and isolate that instance as an example, creates an AMI image, and then move it to forensics, right? Heavy engineering stuff. Now, luckily, I don't have to do all of this by myself. I could, if I choose to, if there is a specific case that I'm really interested in. But then there are other tools for us. Actually, Capital One created this awesome tool, Cloud Custodian. The screenshot that we have is from their website. And it basically has like a configuration file that we define. And we basically say, hey, when you see this event, take this action. And it's nothing but a bunch of, well, I shouldn't say that, that's like oversimplifying, but in a sense, it's a bunch of CloudWatch alerts that are invoking a bunch of lambdas to take certain actions. So you create a security group that is insecure, that opens SSH to everyone. Cloud Custodian will have a rule that goes in and removes that entry, and then puts a log in CloudWatch, for example. That was a super fast coverage. With that, any questions that you guys might have? All right, well, thank you very much.